Welcome to Session 21. A nonlinear system has at least one curved equation, like a parabola or absolute value graph. Today we use substitution to find intersections and the discriminant to count how many intersections exist. When both equations equal y, set the expressions equal. Then rearrange to standard form and solve. Each x value still needs a matching y value. A system solution is a point. After finding x, plug each value into either original equation to find y. The intersections are 3, 7, and -1, -1. If substitution creates a quadratic, the discriminant counts real intersections. Positive means 2, 0 means 1 tangent point, and negative means no real intersection. When both equations are quadratics, the same idea works. Set the expressions equal, solve for x, then substitute back to get the y coordinates. For an absolute value system, split into cases. In the non-negative case, there is no solution. In the negative case, x equals -1, which belongs to the case. So the point is -1, 1. Your turn. Find the intersections of y equals x squared minus 4 and y equals x plus 2. Pause, set equal, factor, and find the y values. Set the equations equal. X squared minus 4 equals x plus 2. Rearranging gives x squared minus x minus 6 equals 0. So x is 3 or -2. The points are 3, 5 and -2, 0. Session 21 recap. Set y expressions equal. Rearrange before solving and use the discriminant to count intersections. Always give coordinate points and split absolute value systems into cases.